In this chapter, we'll be looking at how to solve a problem that we've actually created in using the inverse foot rig. At the moment, the foot appears to work perfectly well. We can lift it and the knee bends. However, as we pull the control further and further away from the leg, the ankle starts to become separated. This would just rip our mesh. Same as if the character moves from the waist up. He can step away and actually leave his feet completely behind. It would be best if we could actually set it up so this leg always tried to keep the distance and stretched out to point at the ankle. We still have yet to actually connect the leg to the spine, so let's do that now for testing purposes. I'm going to pick the nub bone, or that extra little bone we created at the top of the thigh, and I want to link that to the nub bone on the base of the spine. Now when we wiggle the spine, the top of the leg should go. Stretchy bones are actually built into Max as a default. I'm going to open the Bone Tools dialog, and I'm going to turn off the freeze length on this bone so I can do this manually on screen. Now that I've turned off freeze length on the calf bone, you can see that when I pull the nub bone at the end, I can actually stretch out the calf bone. The nub bone isn't moving down because there's an IK solver on it holding it in this place. And I won't allow it to get it any longer. I can actually make it shorter though. The other nice thing is you can actually put squash and stretch onto that bone and actually squash and stretch it if you wanted to. So if this was a cartoony character, this would be a great solution for getting a bit of squash and stretch. I'm going to leave the freeze length on. That is only actually for interactive stretching. We can override that once we wire this to have it automated. We need to be able to get the value, the length, the starting length between this object here, which is the nub bone for the end of the foot, and the top of the thigh. Now, problem is the top of the thigh, this thigh bone, will actually be stretching as well. So we can't include it in the expression, or else we'll have a dependency loop. It's going to be dependent on itself to be able to get the values it needs. What we're going to do is we're going to create a helper object in the form of a point, and we're just going to align that up to the top of the thigh. I'll do it in orientation as well, just to make it neat and tidy. And we're going to link it up to the root bone of the leg. Now we actually have something to pull the position from that's right at the thigh without it being in the hierarchy of these bones here. To get this starting value, I'm going to use MaxScript again, just in the MaxScript listener. I'm going to use the distance command to get that value. I'm going to use $sign again to refer to selected objects. The only problem now is if I just highlight just the $sign and go Shift Enter, you'll see that the $sign doesn't represent a given object because we have multiple objects selected. It returns selection, which is an array of objects. To get to the first one in the array, I want to put square brackets with a number 1 in it. That will return the first object in the array. And distance needs a second object passed to it as well. And this will return the second object in the array. And if I evaluate the whole line with Shift Enter, it'll return the starting length or distance between that point object and the ankle. So now we know what the original starting length was going to be. We're going to have to use this in the math to make sure that we don't have a leg stretching before we want it to. I'm going to start with the nub bone at the end of the leg that's going to stretch the calf. First, again, we need to zero it out to make sure we have a zero value to work with. So I'm going to use the freeze transform option. In the motion panel, I'm going to open up the assign controller window. You can see that it has an IK controller on it because that bone chain is controlled by IK solver. Has an FK subcontroller, and that FK subcontroller has a position list in it, and we're going to be working with the zeroed out X position. I'm going to change the controller on it to be a float expression. The expression editor in Max is an old bit of technology that was added in version 1. A lot of people don't use it anymore, but it's very, very good because it's very fast. Other options like the script controller can be much slower in a lot of circumstances. The expression controller doesn't have as much flexibility as a script controller, but in this instance we don't need that kind of flexibility. Like any expressions, we need to create some variables. Our first variable is going to be a scalar variable. Scalar variable is just a single value, 10, let's say. In this case, I'm going to call it con for constant, and then create, and it puts it in the scalar window. Our con value is actually going to be the original length. I'm going to say assign constant to con, cut and paste that length in and say OK. Con is now equal to that value. We also need to know the changing length between this point helper and the ankle. So I'm going to call those th for thigh, and this is going to be a vector variable, and a vector variable is a xyz position value in this case. And I'm going to say create, and it's added to the vector dialog box here. And I'm also going to create an for ankle, and that adds that as well. We now need to add the objects to these variables to make them become equal to something. It's easiest if you select the object you're going to work with. I'm going to select the variable, say assign to controller, open the controllers dialog, and you can right click on here and say expand objects if need be. And the one that's currently selected on screen will be highlighted in yellow. I want to pick 0.02, say OK. For AN, I'm going to pick the ankle joint, and that is the nub bone on the end of the foot chain. I can't use the nub bone on the end of the leg because, again, this object is part of the equation, and it would create a circular dependency because it would be trying to control itself. So I'm going to use this one on the end of the foot bones. Assign controller again, bone 18, and say OK. The expression is currently a value of 0. That's because we zeroed out the controller on this object, and the x value was a value of 0. We're going to change that now to an expression. We can look in the function list and we can find functions that are available to us. Length v is the one we're going to be using. We don't have a distance command in the expression window. Length v basically gives you the length of the vector v. And that would be, for us, the distance between these two objects from 0, or 0, 0, 0. So length an minus th. An minus th will get us a single vector, and the length will return us the length between this vector and a value of 0, 0, 0. If I say evaluate now, you'll see that the calf bone stretches really long. This is because the current length is actually 49.9. So to subtract that out and get a value of starting value of 0 again, minus con. So we're going to include now our scalar variable and say evaluate, and our knee joint pops back to where it was. The expression isn't done yet because now we have an expression that's stretching that calf bone without a problem, but it doesn't actually allow our knee to bend because it's always just closing the gap on that length. We're also getting no stretch in our thigh bone as well. So let's set it up so that it's actually working on both bones to start with. I'm going to pick the calf bone, freeze the transform on it, and in this case what I'm going to do is go back and pick the nub bone on the end, open the dope sheet editor, find the 0 to X position, and this is the track with the expression controller on it. Right click on it, say copy, so I'm going to copy that controller, pick the calf bone, and on the zeroed out position X track I'm going to say paste, and I'm going to choose instance so that they actually both have one and the same expression running both. I can close this now. Anything I do to the expression on this nub bone will affect the expression on this one. So now when I actually change, you can see that indeed the knee is starting to bend, but in this case it's actually moving twice as fast as it should. Once again, to solve that, I'm going to change the expression. I want to put this whole piece in parentheses so that it calculates that first, and then divide it by 2 and evaluate again. Now it doesn't move twice as fast, but now the problem is it actually gets shorter as we lift the leg and the knee is not bending again. It is indeed stretching the way we like on the way out. So now we have to use an if statement. If statements in the expression editor are a little bit different than they are if you've used them in the Mac script. If C, T, F, and what that basically means, conditional value is T if C is true, else F. So we're going to evaluate C, and if indeed it's true, we're going to use the value of T, and if it's not, we're going to use the value of F, just separated by commas. So first off, I'm going to go and say if, open parentheses, close, and that's going to be for the entire if statement. So greater than 0. So what I'm going to do is I'm going to evaluate this and find out if it's greater than 0. If it is, I'm going to do the next piece here, and because the expression window is so small, I'm going to say enter and move it down to the next line. And if indeed it is greater than, I'm simply going to do the expression again, comma, if it's not greater than 0, be 0. Evaluate again, and now you can see as I lift the leg, the knee bends and the IK solver works as it normally would. But once the leg reaches that extended length, the leg starts to stretch to keep up. Now our last one little problem we have is that our knee is never allowed to go completely straight. To change that, we need to change the value of con a little bit more. We need to make this value a little bit larger. So we can actually experiment by just clicking this up a little bit and saying OK, and seeing where it works best. And that might have been just a little bit too much. Or you could have simply pulled this down to the point at which the leg started to go straight and check the value between the 2 points again to see exactly where you want to do it. Often I find the hit and miss method works perfectly well for me. I think 50.6 looks like it'll work really well. What's nice about this setup now is that foot rolls will even affect it if the leg suddenly gets too long or moved too far. If we lift the character and pull it forward, it'll start to stretch. If If we move the foot down too far, it stretches, keeps its length. Now obviously on a character like this, we don't want really stretchy legs, but this is great because sometimes you just want the character to reach that a little bit further without the foot coming off the ground, and you'll be able to get that now and cheat it without the ankle coming apart.